Hello, and welcome to Lessons with Laurie, where we look at some of the big ideas and concepts taught in mathematics, kindergarten through grade 5. My goal in doing these lessons is to support you, the parent and grandparent, finding yourselves in a new role these days, trying to support the remote or distance learning for your child or grandchild. So with that in mind, in this lesson and in the next, I'd like to look at a really big concept that is taught in mathematics called place value. Oftentimes it happens around in the middle of first grade that students learn about place value. It's a concept that is also misunderstood and shows up later on in mathematics learning for students. Let me show you what I mean. In looking at this example from second grade, students are adding multi-digit problems, students are adding multi-digit numbers, and you might think they have their learning well in hand. They understand place value and how to add 2- and 3-digit numbers. This same student, though, several years later, might write this addition of decimals problem using the same strategy they use for whole numbers and trying to apply it to decimals. They have a big misconception about what decimals mean and what place value means. They don't know where to place the decimal point. They've actually written the problem incorrectly. Before I move on, though, I'd like to make a comment about language. Please try to avoid the sloppy language of reading this problem as 1.32 plus 4.6. To read it correctly, we should be saying 1 and 32 hundredths added to 4 and 6/10, emphasizing place value that's going on in this problem. Well, where does place value begin? Naturally, in kindergarten. When you think about the number 18, students in kindergarten know that it takes 2 digits, a 1 and an 8, in order to write the number 18. There are 4 different versions that you see here of what 18 looks like in the learning progression. We look at 18 counters and want students to be able to circle 10 and know that there are 8 more. Or we place those 18 counters on a double 10 frame and know that it fills one of them, so we have a group of 10 plus 2 more, plus 8 more. Or we take the number 18 and we decompose it into a group of 10 and 8 more. And finally, we write the partner numbers, writing 18 as the addition problem, 10 plus 8, or 8 plus 10. That all happens in kindergarten. In first grade, we then introduce what are referred to as base 10 pieces. And you see in front of me some base 10 pieces. These base 10 pieces are used to help introduce and make sense of what place value is all about. The smallest piece here is called the unit. If I put 10 ones together, that unit, if I put 10 ones together, I get a new unit called a 10. 10 ones give me 1 10. And 10 tens would give us 100. In the classroom, to help facilitate language, though, we often refer to this as the unit, the rod, and the flat. But numerically, they are representing 1 1, 1 10, and 1 100. When students are using these pieces to represent numbers, it helps to, again, solidify that understanding of what place value really means. Because when they then represent the number 32 using base 10 pieces, we want them to recognize that the 2 is in the ones place. It takes 2 units to make the number 32, along with 3 tens. So here's the number 32 made with base 10 pieces. I would want students to be able to sketch this with their pencil, just do a quick sketch of what 32 would look like as well. Included with that, we also want students to understand that 32 can be represented in different ways. 32 could be represented as 3 tens and 2 ones, but it also means it is 2 tens plus 12 more ones, or 1 10 and 22 ones, and finally 32 ones. All four of these representations are important for future understanding. That future understanding happens in this problem. If I ask students to subtract 17 from 32, can you see why it's important to know that 32 has multiple representations? Because when we do the standard algorithm, we're renaming that 32 as a group of 2 10s plus 12 more 1s. So we want students to use base 10 pieces to represent numbers. We want them to be able to do quick sketches. We want them to be able to use a hundreds chart as they explore place value. And on the website, I've written some activities for you to do at home to focus on place value with your child or grandchild. In addition to the hundreds chart, we also use number lines so that students can get a good understanding of what place value means. In the short video that follows, you'll notice that I take you outside to do an activity with place value on a number line. I want to continue the place value lesson outside. You can see that I have put markers on my fence post for each one of the decade numbers, meaning 0, 10, 20, 30, and so on. I made this number line, but there's no reason why you couldn't hand the numbers to your child and ask them to place them correctly. Once they are on the fence post or some other appropriate location, ask them to stand at the number 40. How about 55, 32, 76? How do you know you're correct? And then perhaps change the question, if it's appropriate, and ask them, stand at the number 40, and follow that with the question, how about 1 more than 40? 10 more than 40? How about stand at the number 55, and now 1 less than 55, 10 less than 55? How do you know that you are correct? So all of those sorts of questions that you can ask about place value when students have a physical number line to place themselves on. If you don't have an outside property that has markers that could be used, even in the house, look for appropriate locations where you can make your own number line, or in the hallway of your apartment building, wherever students can physically place those numbers along with themselves.